Hi everyone, I'm Cheryl. In this problem, we're going to sketch the plane curve that is represented by the vector value function r of t equals t cubed I plus t squared j. Now, if you think about this, every time I plug a value in for t, my vector valued function r is going to create a vector. The tips of those vectors, when they're in standard position, will trace out the shape of a curve. So what we're going to do is we're going to try some sample points for t and see if I can see how those tips move. So let's start with a variety of answers or a variety of values for t. Because the domain of my function is all real numbers, you can really choose any value that you like. So let's just start with t equals -2. The x component, or the component that goes along with my vector I, is the t cubed. So -2 cubed is -8. The y component is the component that goes with the vector j, and -2 squared in this case is 4. So the vector that I've created is -8i plus 4j. All right, let's try it again with t being equal to -1. If t is -1, the x component is going to be -1. The y component is going to be a +1. The vector that's created is -i plus j. We're going to do a few more. Let's see what happens when t is 0. 0 cubed is 0, and 0 squared is 0 as well, so that's going to be just the 0 vector. Let's see what happens when t is 1. When t is 1, 1 cubed is 1, and 1 squared is 1, so the vector created is I plus j. We're going to do one more. Let's let t equal 2. 2 cubed is 8, 2 squared is 4, and the vector created is 8i plus 4j. Now, how many of these points should you try? That's really up to you. Get as many as you need to get an accurate picture of the graph. All right, so how does all this information translate to my graph? Well, my first sample, when t equals -2, I'm creating the vector -8i plus 4j. That vector has an initial point at 0, 0, and a terminal point at -8, 4. And so when I draw in that vector, it's going to look like that. And now I can do the same thing for all of my other points. Now you might notice that if I start drawing in all of these vectors, it's going to start looking very cluttered. What I'm really interested in is that terminal point. So I'm only going to be plotting in the terminal points as I move along. So I have a terminal point at -8, 4. I also have a terminal point at -1, 1. So that's going to be right in this location. I have another terminal point created by my 0 vector that's at the origin. When t equals 1, my vector I plus j has a terminal point at 1, 1. And for the vector 8i plus 4j, the terminal point is going to be 8, 4, which will be right here. So again, envision vectors going out to those points. Okay, I only have 5 points, but that's going to give me an idea of what happens to this curve. I'm going to trace along these terminal points. So my graph is going to end up looking something like that. Now, not only do I have the shape of the graph, but I know what the orientation is, because as t gets larger, I know that my graph is moving in this direction. And now I have the planar curve for my vector valued function. I hope that was helpful. Thanks.